Mars. The red planet, Mars, the fourth planet from the Sun, has captivated human imagination for millennia. Known as the red planet, due to its distinctive rusty appearance, Mars represents one of humanity's greatest frontiers for exploration and potential colonization. This celestial neighbor has transformed from a point of light in ancient skies to a world we can study in unprecedented detail through robotic missions and telescopic observations. Physical characteristics and composition. Mars is a terrestrial planet, meaning it has a solid, rocky surface similar to Earth. With a diameter of approximately 6,779 kilometers, Mars is roughly half the size of Earth, making it the second smallest planet in our solar system after Mercury. Its mass is about 11% that of Earth, resulting in a gravitational pull that is only 38% as strong as what we experience on our home planet. The planet's most striking feature is its distinctive red coloration, which results from iron oxide covering much of its surface. This oxidized iron gives Mars its characteristic hue that can be observed even with the naked eye from Earth. The Martian surface is composed primarily of basaltic rock, formed from ancient volcanic activity, along with significant deposits of various minerals including sulfates, chlorides, and hydrated silicates. Mars has a thin atmosphere composed mainly of carbon dioxide, with small amounts of nitrogen and argon. The atmospheric pressure at the surface is less than 1% of Earth's, making it insufficient to support liquid water under most conditions. This thin atmosphere provides little protection from solar radiation and contributes to the planet's extreme temperature variations. Orbital mechanics and seasons. Mars orbits the Sun at an average distance of 227.9 million kilometers, taking approximately 687 Earth days to complete one orbit. This lengthy year is nearly twice as long as Earth's. The planet's orbit is more elliptical than Earth's, causing significant variations in its distance from the Sun throughout the Martian year. One of Mars's most fascinating characteristics is its axial tilt of 25.2 degrees, remarkably similar to Earth's 23.5 degree tilt. This similarity means Mars experiences distinct seasons, though they last roughly twice as long as Earth's due to the longer orbital period. The planet's day, called a sol, is only slightly longer than Earth's at 24 hours and 37 minutes. The elliptical orbit creates dramatic seasonal differences between the northern and southern hemispheres. When Mars is closest to the Sun, it's summer in the southern hemisphere, leading to intense dust storms that can engulf the entire planet. These global dust storms can last for months and significantly affect the planet's weather patterns and surface temperatures, geological features, and topography. Mars boasts some of the most spectacular geological features in the solar system. The planet's topography reveals a rich history of volcanic activity, water erosion, and tectonic processes that have shaped its surface over billions of years. Olympus Mons, the largest volcano in the solar system, rises approximately 21 kilometers above the surrounding plains, making it nearly 3 times taller than Mount Everest. This massive shield volcano covers an area roughly the size of the state of Arizona and represents one of the most impressive geological formations known to science. The Valles Marineris Canyon system stretches over 4,000 kilometers across the Martian surface, reaching depths of up to 7 kilometers in some places. This vast canyon system dwarfs Earth's Grand Canyon and provides valuable insights into Mars's geological history and the processes that shaped its surface. The northern and southern hemispheres of Mars display markedly different characteristics. The northern hemisphere consists primarily of smooth, low-lying plains, while the southern hemisphere is dominated by heavily cratered highlands. This dichotomy suggests different evolutionary histories for the two regions and continues to puzzle planetary scientists. Evidence of water and potential for life. Perhaps the most compelling aspect of Mars is the mounting evidence for the past and present existence of water. Numerous features on the Martian surface suggest that liquid water once flowed abundantly across the planet. Ancient riverbeds, lake basins, and mineral deposits that form only in the presence of water paint a picture of a very different Mars in its distant past. Recent discoveries have revealed the presence of seasonal dark streaks called recurring slope linea on Martian slopes. These features appear and disappear with the seasons and may indicate the current presence of liquid brines flowing on the surface. Additionally, radar data suggests the existence of a large underground lake beneath the planet's southern polar ice cap. The search for life on Mars has intensified with each new discovery. While no definitive evidence of past or present life has been found, the planet's history of water activity and the discovery of organic compounds in Martian soil have heightened scientific interest. Mars likely possessed conditions suitable for life during its early history, when it had a thicker atmosphere and liquid water on its surface. Moons and orbital dynamics. Mars has two small, irregularly shaped moons, Phobos and Deimos. These tiny satellites are thought to be captured asteroids given their composition and irregular shapes. Phobos, the larger of the two, orbits very close to Mars and completes 3 orbits in a single Martian day. Its proximity to the planet means it's gradually spiraling inward, and will eventually either crash into Mars or break apart to form a ring system. Deimos, the smaller and more distant moon, has a more stable orbit and takes about 30 hours to orbit Mars. Both moons are heavily cratered and composed of dark, carbon-rich rocks similar to certain types of asteroids found in the outer asteroid belt. Climate and weather patterns. Mars experiences a harsh and variable climate characterized by extreme temperature fluctuations and dramatic weather events. Surface temperatures can range from about 20 degrees Celsius at the equator during summer to -125 degrees Celsius at the polar regions during winter. The thin atmosphere provides little insulation, causing rapid temperature changes between day and night. The planet is famous for its dust storms, which can be local, regional, or occasionally global in scale. These storms are driven by temperature differences and can last for weeks or months. The fine Martian dust is easily lifted by winds and can create atmospheric phenomena that significantly alter the planet's appearance and affect solar radiation reaching the surface. Seasonal changes bring additional weather phenomena, including the formation and sublimation of polar ice caps composed of both water ice and frozen carbon dioxide. These seasonal processes create winds and pressure changes that drive much of Mars's weather patterns. Exploration, history, and future missions. Human fascination with Mars dates back to ancient civilizations, but scientific exploration began in earnest during the space age. The first successful mission to Mars was NASA's Mariner in 1965, which provided the first close-up images of the Martian surface. Since then, dozens of missions from various space agencies have studied Mars from orbit and on the surface. Notable missions include the Viking landers in the 1970s, which provided the first detailed surface analysis, the Mars Pathfinder and its Sojourner rover in 1997, and the highly successful Mars exploration rovers Spirit and Opportunity, which far exceeded their planned mission durations. More recent missions like the Curiosity and Perseverance rovers have advanced our understanding of Mars's geology, climate history, and potential for past life. Current and planned missions continue to push the boundaries of Mars exploration. The Perseverance rover is actively searching for signs of ancient microbial life and collecting samples for future return to Earth. Multiple space agencies are planning Mars sample return missions, human exploration programs, and long-term colonization efforts. Implications for humanity's future. Mars represents humanity's most likely destination for permanent settlement. Beyond Earth, its relatively moderate climate compared to other planets, the presence of water, ice, and a day length similar to Earth's make it the most feasible option for human colonization. The challenges are enormous, including radiation exposure, resource utilization, and the psychological effects of isolation. But technological advances continue to make Mars exploration and settlement increasingly possible. The study of Mars also provides crucial insights into planetary evolution, climate change, and the conditions necessary for life. Understanding how Mars transformed from a potentially habitable world to its current state offers valuable lessons about planetary atmospheres and climate systems that may inform our understanding of Earth's future. Mars continues to challenge our understanding of planetary science while inspiring dreams of human expansion into the cosmos. As we stand on the threshold of potentially sending humans to Mars within the next few decades, this red world represents both a scientific frontier and a symbol of human ambition to explore and inhabit the universe beyond our home planet.